Okay, today class we're going to be talking about direct variation. It is a particular type of function that is in the form y equals kx, where k is just a number that is not equal to 0. So y and x are just y and x, and then k is some number that you multiply by x. And that's a direct variation. The constant of variation for a direct variation is k. So this k, the number that's before the x, is called our constant of variation. And it's the coefficient of x. And it says that k is the coefficient of x are said to vary directly with each other. Okay. Example 1, it says, is each equation a direct variation? If so, find its constant of variation. Well, in order for us to be able to do that, we have to find out if the equation is in the form. We have to first get the equation in the appropriate form. So the appropriate form for that would be y equals kx. So we need to get y by itself. So I'm going to do that here. Let's see, make that a different color here. Y equals kx. We need it in that form. Okay, right now we have a number times x plus a number times y equals 0, but we don't want that. We want this x to be by itself. The y to be by itself. So what we need to do is we need to isolate this term right here. It needs to be isolated. Okay, if we subtract 5x from both sides, okay, if we subtract 5x from both sides of the equation. All right, so then what will happen is our 5x's will cancel. All right, so those will cancel, and we will be left with 2y equals, and then on the other side we're going to have 0 minus 5x, so that's just minus 5x. All right, so basically all we did is we took the 5x and moved it to the other side. On the other side it becomes negative. So that helps us to at least get the term with y by itself. But if you notice, y in the correct form is y equals kx. So we need to get rid of the coefficient before the x. All right, so in order to do that, we need to solve this for y. Y is being multiplied by 2. So if we divide both sides of this equation by 2, then that's what will happen. We will cancel that, and we will get y equals, and then negative 5 halves x, okay? When we divide by 2, that's negative 5 divided by 2. We're just going to leave it as a fraction. So you would get negative 5 halves x. All right, so now the question asks us, is it a direct variation? Well, we have to ask ourselves, is it in the form y equals kx? We need it to be right here, just like in this form, y equals kx. Well, we have the y by itself, we have an equal sign, we have some number, it's a fraction, but we do have a number, and then an x. So we can say yes, it is a direct variation because it is in the correct form that we need. So we can say yes, and then it asks us, what is the constant of variation? Well, that's the number that is right next to the x, which is negative 5 over 2. So that is our constant of variation. But in order for us to have found out that it was a direct variation, we had to go through this process where we get the y by itself. Okay, we're going to have to do the same thing on b. All right, on b, right now it's 5x plus 2y equals 9, but we need the y right here. We need this whole term to be isolated, which means we need to kick the 5x to the other side. So if we subtract 5x from both sides, it will cancel on the left and it will be added to the right. Okay. All right, so our 5x's cancel. On the left we get 2y equals. Now we have 9 minus 5x. Okay, 9 minus 5x. Now, the y is not completely by itself yet. It has a 2 there. So we actually need to divide now everything by 2. And we're going to divide this whole side by 2. All right? This is going to cancel, and we get y equals Okay, we have to divide each of these terms by 2. So 9 divided by 2, okay, would just leave it as a fraction. We get 9 over 2 minus, and then 5 over 2x. This is an equivalent expression if we write the fraction and then with the x. So we have to look at it and say, is it in the form y equals kx? Well, we do have y by itself. We have an x with a term in front of it, but then we have this extra term stuck in here. Because of that, we have to say no, it is not a direct variation because there's an extra number in there. All we're looking for is a y and then a number with x. But we have a y and then a number with x, but then we have this extra number, which makes it a no. So this one does not vary directly. So on each of those, you actually do have to get the y by itself before you can do anything with that problem. Okay, so example 2. Example 2, it says write an equation of the direct variation that includes the point 4, -3. Okay, so step 1, we're going to actually just use, we're going to write down the direct variation equation, which is y equals kx. Now, what we're going to do first, the first step is to plug in 4 and -3. 4 is the x value, and -3 is the y value. So we're going to plug those values right in over here. Okay, so we're going to take these values and plug them into the y and x over here, which will give us -3, because that's our y. -3 equals k times x, which is 4. Okay, so what we have to do is we have to find x. We write the direct variation equation, then we solve for x. For k. We need to find out what our k is. So then we can divide both sides by 4 to get the k by itself. So we see that our k, which is our constant of variation, we see that that is -3/4. So that's our first step, is to just find k. All right, that's our first step. And then our next step will be to fill in and write our equation again, y equals kx. But this time we fill in our k. So the first time we plug in x and y, find our k, then we write the equation, which is just y equals, and then our k is -3/4 x. So this right here is our equation. Okay, so the first time you write the equation, you plug in your x and your y to find k. Then you take your k and plug it in to k on the direct variation equation. And that's how you do that type of an example. That's if it says to write an equation given a point. Okay, that's how you would do that. Okay, so now let's look at example 3. Your distance from lightning varies directly with the time it takes you to hear the thunder. Okay, if you hear the thunder 10 seconds after you see the lightning, you are about 2 miles from the lightning. Write an equation for the relationship between time and distance. So our two variables are time and distance. Now, the distance, how far away that the lightning is, depends on how many seconds you hear the thunder. So our time is our x. It's our independent variable. So we're going to let x equal time, and y is going to equal the distance. All right, so if we look at this, our time, we know that x equals, time is 10 seconds, and y equals 2 miles. All right, so there's our x and our y value. So we're going to do it just like we did example 2. Example 2, we had to write the equation y equals kx, and then we fill in the values for y and x. So for y, we get 2. So we do 2 equals, and then we do k times 10, because we know our x and our y value based on what they told us in the problem. And then we want to get k by itself. So in order to get k by itself, because that's what we want to find out, we're going to divide both sides by 10. Okay, that will go ahead and give us k by itself. So it looks like k is 2 over 10. K is 2 over 10, which reduces to 1/5. So our k is 1/5. So then our equation, so now we take this k and plug it back into y equals kx. So you have to write the equation twice, but the first time you plug in x or y to get k, then you just go ahead and plug the value you got for k in. So you get y equals 1/5 x. All right. And that will be our equation for direct variation. Okay, so let's look at the next example. The next example tells us, okay, you can determine whether or not x varies directly with y. You can use the ratio y over x to see if k is the same for every point. So the following examples use the ratio y over x and see if k is the same for every point. If so, write the equation for each table. So what we need to do, the reason this works is our equation is y equals kx. Okay, that's our equation. And the way that they get that ratio for k, in order to find out what that ratio for k is, the way they got the y over x is if you get k by itself, you take y divided by x. Okay. If you do that, your k is going to be y over x. Y divided by x. So what we can do then on these tables is we can take y divided by x on all of these and see if we get the same thing each time. So if we do 2.25 divided by a -3 on this chart here, we're going to do that. And we're going to see if they're the same. I'm just going to divide each one in the calculator. So if we get -3 divided by 2.25, you end up with 1.33. I'm sorry, I did that backwards. 2.25 divided by 3. Okay, I'm sorry. You do that backwards. Y divided by x. So you do 2.25 divided by 3, and I get 0.75. We're going to see if we get the same thing all the way through. If I take 0.75 divided by 1, well, that's just going to be 0.75. And actually, they're negative. That was negative. Negative divided by positive is negative. So you get negative 0.75. Okay, -3 divided by 4. You're going to get 0.75 also, negative 0.75. And then again, I'm going to do negative 4.5 divided by 6, which again is also 0.75. So these are all equivalent to negative 0.75. So we would say, yes, it is a direct variation. And our k is going to be these values right here. So to write our direct variation equation, you just take the formula y equals kx, and you plug the negative 0.75 in for k. So we have y equals kx, and then we plug that 0.75 in for k because that is what our k is. So we get y equals negative 0.75x. That would be the equation for this table. And I could only say this because all those values were negative 0.75. If any of those values had been different, we would have had to just say no, and we wouldn't have been able to write an equation. And I believe actually the next one does that. I believe the next one, if you divide them out, they're not going to be the same. So on part B, so we take y divided by x. Y divided by x, we get negative 1 over 2. Negative 1 over 2, which in decimal form is negative 0.5. And then we get 1 divided by 4, and already we see these fractions aren't the same. This is going to be negative 0.5. This is going to be 0.25. So we would just have to say no, and we can't write an equation. So the only way that would work is if your table value is exactly the same each time. If it is, then you can say yes, and you can write the equation of direct variation. That is how you do problems with direct variation. Thank you for listening.